everyone. Welcome to episode number 646 of this here electronic engineering podcast called Amelia's Weekly Fish Fry, brought to you by eejournal.com and written, produced, and hosted by me, Amelia Dalton. Folks, this week we're talking about VITA, MOSA, and Mission Critical Distributed Processing Systems. My guest is Daniel Toohey from Mercury Systems, and we're discussing the new VITA 100 standard, how MOSA aligns with VITA, and the critical role that system management plays in distributed systems. Also this week, I check out new research that questions long-held assumptions about where life can exist in the solar system, and maybe mean that life on Mars does exist, just under the surface. But first, please welcome Daniel to Fish Fry. Hi, Dan. Thank you so much for joining me.
Hi.
Okay, so we're talking about VITA 100 and mission critical distributed processing systems today. But Dan, before we get started, tell me a little bit about Mercury Systems.
Mercury Systems is a leader in mission critical processing at the edge. We continuously invest in innovation that matters to solve the most pressing aerospace and defense market challenges. Combining technologies and expertise developed for more than 40 years, a Mercury processing platform offers our customers the full breadth of signal processing from RF front end to the human-machine interface, which enables our customers to turn data into decisions with standard products and custom integrated solutions.
Fantastic. Now, there was a recent reaffirmation of MOSA by the DoD, and that plays an important role here. So, talk to me about how MOSA aligns with VITA, and how do MOSA tenants map back to VITA designs in the field?
Sure. The DoD directive that you are referencing establishes 5 pillars for MOSA. I believe that each of these mirrors principles that the VITA Standards Organization, or the VSO, has been following and in some cases driving since its inception. Establishing enabling environments and leveraging consensus-based open standards are 2 of the DoD pillars for MOSA. I personally consider the VSO as a MOSA enabling environment itself. The VSO is responsible for the creation, storage, distribution, and maintenance of consensus-based open standards like VITA 65, which is also known as OpenVPX. These VITA standards and others are being leveraged by DoD primes today to meet their program-level MOSA requirements. Employing a module design, designating module interfaces, and certifying conformance are the 3 remaining DoD pillars for MOSA. One only needs to open a copy of OpenVPX to understand how the VSO workstream and outputs address these principles. Requirements within the OpenVPX standard include a recommended method of verification, which is often leveraged by implementers and adopters of the resulting products to generate the artifacts that demonstrate conformance to DoD MOSA requirements. The OpenVPX requirements define a set of modular hardware elements such as payload modules and backplanes. OpenVPX additionally defines the hardware elements associated mechanical, electrical, protocol, and in some cases, software interfaces. OpenVPX hardware elements and these interfaces enable MOSA distributed processing subsystems, which utilize computational resources across multiple physically separate nodes and messaging protocols to achieve a common goal.
All right, so let's step back a bit and talk about distributed systems a bit. What role does system management play in these types of systems?
System management plays a large role in traditional distributed processing systems. System management facilitates adaptability, such as replacing a hardware element within a system with the next generation element on the roadmap, or relocating a hardware element from one subsystem to another. System management also eases performance optimization, for example, by maintaining inventories of hardware elements and allocating them to applications as they are needed. System management also enables resiliency through the supervision of available redundant hardware elements, including maintenance-related prognostics. System management improves operational efficiency by facilitating automation of configuration-related activities and remote management. And finally, system management can support system security through capabilities and features such as authorization, access control, and auditing.
Okay, so VITA 100 is a new kind of standard creation process planning, right?
We plan to create, maintain, and leverage a model-based system engineering or MBSE model to assist us in the creation of the VITA 100.20 standard. We want the model to serve as the authoritative source of truth for standard content, and we intend to generate portions of the standard directly from the model. We also plan to capture user needs in both requirements and use case form within the model and include traceability between the two. We desire to avoid the creation of requirements that do not trace back to some documented user need, and we also plan to prioritize our VITA 100.20 content and our working group meeting workflows to address the documented user needs. Finally, we plan to capture acceptable conformance methods for the requirements within the model as well and trace them back to the requirements. We want to shape requirements such that conformance testing is not only realizable, but also such that the verification testing is expedient, effective, and economical. We expect putting some expectation on conformance methodologies from the start will lead us to a better set of requirements for the MOSA community.
Okay, so can you share an example of VITA 100 in action?
Sure. One of the first and probably most common uses of VITA 46.11, which happens to be system management for VPX, relates to power management of hardware elements within an open VPX subsystem. The ability to enable or disable payload power on an individual hardware element in a distributed processing subsystem is minimally useful for things like fault management and power management purposes. However, in the existing VITA 46.11, there are no security protections on the interface to the hardware elements. That means that something else could be on the IPMB, either a fault or a malicious actor, and could cause an unintended payload power enablement or disablement. In VITA 100.20, we plan to maintain the ability to enable and disable payload power on hardware elements within a VITA 100 subsystem, but we'll also add the security functions. VITA 100.20 will support authenticated and encrypted messaging between management agents on hardware elements, and this additional security can be used to mitigate the impact of unexpected messaging within the system.
All right, Dan, it is time for your off-the-cuff question. So, if you could have one meal right now, it doesn't matter if it's on the other side of the world, you need a passport to get there, what would you have?
I think I'll have like a bacon cheeseburger on steroids from Bad Daddy Burger.
Awesome. Well, Dan, I think that's all I have time for today. Thank you so much for joining me.
Thank you, Amelia.
Does life exist on Mars or the icy moons of our solar system? Well, for years, the general idea was no, life does not exist in these places. But there is new research out of NYU Abu Dhabi that questions this long held belief. We just might not have been looking in the right places. So, a new study out of NYU Abu Dhabi has found that high energy particles from space, known as cosmic rays, could create the energy needed to support life underground on planets and moons in our solar system. This new study contends that in certain environments, cosmic rays could actually help microscopic life survive underground, which does challenge the traditional view that life can only exist in areas that are near sunlight or volcanic heat. So, this new study, which was recently published in the International Journal of Astrobiology, focused on what happens when cosmic rays hit water or ice underground. The impact of these cosmic rays actually breaks the water molecules apart, which releases electrons. And as we know from bacteria here on Earth, that some bacteria can use electrons for energy using a process called radiolysis, even in the coldest, darkest environments with absolutely no sunlight. So, using computer simulations, this team from NYU Abu Dhabi researched how much energy this process could produce on the moons of Saturn and Jupiter and on Mars. These moons in particular are interesting because they are covered in thick layers of ice. But it is believed that there is water hidden underneath the surface. And what they found was really interesting. Saturn's icy moon Enceladus had the most potential to support life, followed by Mars and then Jupiter's moon Europa. The study also introduced a new idea called radiolytic habitable zone. Okay, so there is a term called the Goldilocks zone, which you may know is an area around a star where a planet's surface temperature could potentially allow for liquid water. But this new zone actually focuses on places where water exists underground and can be energized by cosmic radiation. And imagine how many places where cosmic rays can be found in space. That means there could be so many more places in the universe where life could exist. So what does this mean? Well, it could provide new guidance for future space missions. Instead of seeing signs of life on the surface, scientists might also explore underground environments on Mars and these icy moons, using tools that can detect chemical energy created by cosmic radiation. The lead researcher on this project, Dimitra Atri, explains the impact of this study like this. This discovery changes the way we think about where life might exist. Instead of looking for warm planets with sunlight, we can now consider places that are cold and dark, as long as they have some water beneath the surface and are exposed to cosmic rays. Life might be able to survive in more places than we ever imagined. Super cool, right? So, if you want even more information about this cosmic ray study or more information about Mercury Systems, I've included a couple links below the player on this week's Fish Frying page on eejournal.com and in the description for this week's YouTube episode as well. Hey, have you checked out EE Journal on social media yet? Well, you should. You can find us at facebook.com/EEJournal. If LinkedIn is more your thing, I dig it. You can follow us or me on LinkedIn, and we are also on Blue Sky Social and Mastodon too. And we have a YouTube channel, youtube.com/EEJournal. Folks, it is chock full of all kinds of techie videos, including our very popular Chalk Talk webcast series and our animated series called Libby's Lab. And of course, you can subscribe to our EE Journal YouTube channel as well. I'm just saying. Thank you, everyone, for tuning in. If you know of any cool new technology or heck, you just want to chat, shoot me a line at Amelia, that's Amelia, at eejournal.com, or post a comment on our forums on EE Journal. For the week of August 22nd, 2025, I'm Amelia Dalton, and you've been fried.